Welcome to Chapter 20, the last chapter of this course, Introduction to Data Science. I hope you guys have had a good time. I've kind of had a good time. Kind of exploring and getting to know data science a little bit more. So today we're going to concentrate on big data. We're going to talk about what it is and why it's important and when it's used. And then we're going to demonstrate one of the methods that R has for actually dealing with big data. Now, first, big data has sprung up recently in the wake of, especially barcodes and UPCs and internet data collection, and it gathers an unprecedented amount of types of data. It's also going to link all of this data in ways that we've never been able to link them before. So, of course, this massive amount of data is still subject to the concept of garbage in and garbage out and anomalies and those things, and we'll kind of talk about some of those later on. But there are three characteristics that make big data different from any of the data that we had before: volume, velocity, and variety. Now, volume refers to the sheer amount of data. When we're talking about internet mining and things like that, we're talking, volumes and volumes of data. Velocity focuses on how quickly your data is going to arrive and how quickly that data becomes outdated. Okay, it is the speed at which it is usable. And then finally, variety reflects on the fact that there can be many different kinds of data, and it can be stored in many different ways. This model is known as the 3V model of big data. These 3Vs are very common on their own, but it's the interaction and the grouping of all three working together, and that's what sets this big data apart. Conventional statistics works on small data, but do those same statistical operations work on big data? Typically not. These statistical methods were designed to work with very small samples, even samples of full data, right? But let's say we're actually looking for a needle in a haystack. We're not using it as a metaphor, okay? Well, we actually want to see much larger samples because the probability of us finding that one needle in the haystack increases if we choose a larger sample, right? Makes sense. Machine learning is the ability to automatically learn and improve from experience without being explicitly programmed. So you can see how machine learning is really going to benefit big data. You don't have to program one by one. It's going to learn on its own. Okay, so when you're searching for that needle in a haystack, you want your haystack to be as big as possible, but then you also want your computer to be able to learn and understand on the fly what you're looking for. Now, some cautions to look out for. The more complex something is going to be, the more difficult it is going to be to clean. Remember, cleaning is step one. The unpredictable nature of those rare and unusual cases, it is always going to be present. This could throw a wrench into your learning or your modeling, okay? So remember to always keep those in mind. Finally, linking data sets together is going to provide additional value in most cases, except that linking is going to increase complexity, okay? The other thing that linking can do, depending upon who and or what you are linking with, you can start to have privacy issues and concerns of your data being compromised because you may not have full control over that data. There are some tools available out there for big data. Hadoop has its HDFS and MapReduce parts. That's just one of the ways. This is the one that we're going to go into a little bit more in R, but we'll talk about some of the other ways at the end. The two most important frameworks for Hadoop are the HDFS and MapReduce. Now, HDFS is going to cluster multiple computers and gets them to work together. The cluster is going to work as one large computer. This is going to give huge throughput, okay? Major throughput is going to go on. Now, MapReduce is going to follow that same logic, but it's going to break up into two different processes, mapping and reducing. Now, mapping is going to have one large job broken up into many different smaller parts that can then be distributed to various machines. Reducing then is going to be taking all of the output from all of those jobs and putting them and piecing them back together again. So let's look at the Hadoop and the what we can do in R. So again, new package alert. You do need to install and activate the Hadoop and the RH Hadoop. Nope, R Hadoop, that one. R Hadoop in order to use them. They are not automatically in there. Now, R Hadoop is an R interface or a wrapper for Hadoop. Here, we're creating a list of integers from 1 to 10, but we're storing them as a distributed file system or a DFS, okay? Instead of a vector or a list or whatever it was, however we saved it prior. The DFS stands for distributed file system. Now, this second function here is going to use that map, okay? It's going to do same thing as the lapply that we've used a couple lectures ago. So here the arguments are the DFS, which is the input equals DFS, right? The map equals the function, and then we have a key val. Now, this key val is going to be a helper function. So what this is saying is on an input of v, we want to square v as the output. We're just doing a very, very simple example here. Its first argument here, v, that's going to be the integer to which the process is applied, and then the second is going to be the v squared, and it's going to be the output. Now, that's just one way to work with it. We're not going to work too much more with big data here. We're just kind of trying to give an overview and know that it's out there. There are more specialized courses in big data. So, but there are also other ways of dealing with big data out there. Hadoop is only one. So one analyst on one computer can only handle whatever memory that computer has. So you can do a few different things. You can simply downsize the data sample in order for it to fit and run on one machine. But we've talked why we may want the big data in the first place, so that may not be an option. So option 2, get a bigger computer. Again, may not be an option. Finally, the third option is something out there that is usable. There are options in R and packages that use hard drive capacity as storage instead of the memory capacity. Hard drive's fairly cheap, and this could increase that computing power of the computer while keeping the data sample the same. So I have enjoyed this course with you guys so much. Sad it's coming to an end, but bittersweet, right? Please do not forget to upload your final project and the presentation. And as always, with any class, I'm here for any questions, always available through email no matter what. And for the last time, happy coding.